So the next experiment we're going to look at in terms of experiments that help shape the understanding of quantum mechanics and is the photoelectric effect. Now, an interesting story behind this is that this experiment and the resulting theory that came out of it was the reason why Albert Einstein earned the Nobel Prize. And he later went on to do more popular theories in general relativity, but you can only get the Nobel Prize once in a specific field. If you're a boss like Marie Curie, you can actually get a Nobel Prize in two fields. She got it in both chemistry and physics. Einstein only had his in physics. So this was his first seminal contribution to the field of quantum mechanics. And so this is what he got his Nobel Prize for, though he probably could have earned a couple more if that were a thing, but I guess we got to share that around. So what the question was what this experiment was trying to figure out was, can electromagnetic radiation be emitted at any energy? And there was no experimental evidence available. And what I mean by this is that so we have we know that light, so electromagnetic radiation, has a couple different properties as it's propagating. One is the wavelength, or we could call that 1 over the frequency, or it's related to. It's not exactly. We have speed of light, and we also have the amplitude of the wave. So we have these two ways to describe the wave: the wavelength or the corresponding frequency. Again, those go together, or the amplitude. Okay, and so the question was, can this radiation, we're going to use this. Can it be emitted at any frequency or any energy? And so the way they did this was, we had a metal plate here, and they used different metal plates. This was attached over here, another metal plate. We had a light source. So this is our light source that we could change things, such as the frequency or the amplitude, or the main two. We would shine light at the metal. This metal was then connected to a voltmeter, and we had a difference in potential. So this was negative, this was positive. And so what the thought was is that the goal was to, we have electrons. We can just kind of put them here as being, we know that electrons are held more loosely on a metal than other substances. And so we want to figure out if we could eject electrons from the metal. So you can. And then once the electrons are ejected, they can go and they will accelerate to the plate that is positively charged by attractive forces. So we're ejecting electrons from this plate. They're going to have kinetic energy. And so the variables are, we can change the energy or the amplitude, or how much light, intensity of how much light we have. We can also measure the amount of energy it takes, and then the kinetic energy that the electrons come off the plate with. And so that's the basis for the photoelectric effect. And so what we're going to do is we're going to look at a simulation of how this works, and then we'll come back and explain our observations.